Okay, I've had a request to work some problems from the third homework assignment. This first problem, we were given an order. We are supposed to give 165 milligrams by IV. The directions on the package state, reconstitution of the single-use vial with 4.8 milliliters yields 250 milligrams per 5 milliliters. How many milliliters will you administer? So what we want to do is we want to take the order, which is 165 milligrams, put that over 1, and then we're going to multiply this, use this as our unit fraction. This is telling us how to mix it up. It actually does not have anything to do with the way we solve the problem. I'm looking for how many milliliters I will administer, so I want the milliliters in the top, I want the milligrams in the bottom to cancel out. So I'll put 250 milligrams here. And I put 5 milliliters here. The milligrams cancel out. You can either multiply straight across and then reduce it, or you can reduce it top and bottom. And when I look at this, I see that the 5 and the 125 cancel out. If I divide that by 5, I get a 1. Divide this by 5, and I get a 50. So I multiply across, and I get 165 milliliters per 50. And then I do that division, and I get 3.3 milliliters, which is your answer. You should be giving 3.3 milliliters of that drug. Okay. The next problem. What is the strength expressed as a percent of an 800 milliliter solution that contains 120 grams of dextrose? The thing for us to remember is that the solute over the solution gives us the strength. Usually the solute is in grams and this is in milliliters. So if we want to know the strength, what we do is we take the solute, the amount of whatever it is we're supposed to be dissolving, 120 grams, and put that over the solution, which is 800 milliliters. Okay, you divide 120 by 800, and you should get 0.15, which is 15%. So this is a 15% solution. Next problem. We have an order for 8 grams divided in 4 doses. The directions on the package state, add 4 milliliters to suitable diluent to yield 1 gram per 2.5 milliliters. How many milliliters will you administer per dosage? The patient weighs 160 pounds. Well, it turns out this is extra information. It doesn't affect anything. We actually don't need this as well for the same reason we didn't need it earlier. It tells us how to mix it. It doesn't actually, figure into these calculations. So our order is for 8 grams per day. I'm going to come back and deal with the divided doses in a minute. Okay? Then I want my strength to be, it's going to yield 1 gram for every 2.5 milliliters. I'm looking to find out how many milliliters I'm going to be administering per day. That's where we are right now. So I'm going to put the 1 gram in the bottom, so it cancels out the gram here. And then 2.5 milliliters up here. Well, the grams cancel out. Do the multiplication, and you get 20 milliliters per day. That's the total day's dose. We're supposed to do this into 4 doses. So we take that 20 milliliters and divide it by 4, the number of doses, which gives me 5 milliliters per dose. If I had to guess, I would say that your mistake was not realizing it was in 4 doses. Next problem. Penicillin was ordered 300,000 units IM every 12 hours. The label on the vial reads that it's 600,000 units per milliliter. How many milliliters will you administer? Okay, so we start off with the order, which is 300,000 units over 1. The vial has 600,000 units per milliliter. That's per 1 milliliter there. And I want to cancel out the units because I'm asked how many milliliters. So I'm going to put the 600,000 units in the bottom. And that's for 1 milliliter in the top. Now we can cross cancel here. If I divide this by 300,000, I get a 1. Divide this by 300,000, I get a 2. Units cancel out. So I have 1 over 2. Half a milliliter is what I'm supposed to give, which is what they're looking for, is 0.5 milliliters is the answer they want. Okay. What is the strength expressed as a percent of a 200 milliliter solution that contains 10 grams of dextrose? This is very similar to the problem we worked earlier. We take the solute over the solution to find the strength. So I'm going to take this 10 grams and put it over the 200 milliliters. Do the division. 10 divided by 200 is 0.05. which translates to 5%. This is a 5% solution. Okay, now last one. How many 10-gram tablets would you need to prepare 750 milliliters of a 1 to 5 solution? Okay, 1 to 5. This is the same type of thing we had here. This is another way of expressing the strength. It's grams over milliliters. So 1 gram per 5 milliliters. First thing I want to do is to figure out how many grams I'm supposed to give total, and then worry about the tablets at the end. Okay, so I know I have 1 gram for every 5 milliliters. I'm supposed to prepare 750 milliliters. So I'm going to multiply by 750, and the milliliters on the top, so it cancels out here, and I'll put that over 1. That cancels out. And I have 750 over 5. If I divide 5 by 5 by 5, I get a 1. 750 divided by 5 is 150. So my total dosage is supposed to be 150 grams. Now I'm supposed to find out how many tablets that would be. All right. I have 10 grams for every 1 tablet, right? All right, so this is another way of talking about this. So my order is 150 grams. And I want to use this. Now I want my grams to cancel out so I can have tablets in the top. So I'm going to put 1 tablet in the top over 10 grams for each tablet. The grams cancel. If I divide this by 10, I get a 1. Divide this by 10, I get a 15. Your answer is 15 tablets.